Hey folks, welcome back. I just wanted to go ahead and welcome you to P.2. Today we talk about properties of exponents and scientific notation. The first thing you're going to do for your warm-up today is if you're, well, of course, a person using notebook paper, you're going to go ahead and copy down those things that I have highlighted there for you. And then you're going to go ahead and take a few minutes to evaluate the expression when A is 3 and B is 4. So you can go ahead and take a few minutes to do that. Go ahead and hit pause, and you're going to see your answer in just a few moments. Did you get them right? Here's hoping. Usually the one that causes the most trouble is, I think it's part 5 there, if you take a look, because some of my students will try to reduce the 4s, like try to cancel this 4 and this 4. But what you need to keep in mind is that anything touching a plus or a minus, so this factor of 12 on top is touching a plus sign, that makes it a term. So this 12 here is a term, which means we're not allowed to reduce this 4 and this 4. They have to stay there. And again, that is situated in that exception with the order of operations. You got to work out the little mini math problem on the top, little mini math problem on the bottom. Feel free to email me if you had any questions with those. All right, a little bit of an activity. You can go ahead and pause. You're going to go ahead and take a few minutes to try your best to answer some of those questions there. So you can go ahead and press pause now. All right, let's take a few minutes to go ahead and go over that. So, number 1, 2 times 2 times 2 times 2 times 2. Hopefully you wrote that as 2 to the 5th. You could also write it as 32, but we were just looking for you to write it with an exponent. And then if you have x times x times x times x times x, accordingly, that would be x to the 5th. And then if you have that same thing, 1, 2, 3, 4, 5, 6, 7 x's there, we would write that as x to the 7th. This guy here is x to the 4th. And then, I don't know if you noticed or not, but they said, hey, well, take your x to the 7th and multiply it by your x to the 4th. So what do you end up getting when you do that? Well, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's all multiplied together. So the product of those two things is actually x to the 11th power. Let's try it again with x to the 5th times x to the 7th. So you have 1, 2, 3, 4, 5, 6, 7. So you actually have x to the 7th power as the product of x to the 5th and x squared. So what can we conclude from this? Well, more or less what I see is that we are going to go ahead and add our exponents when you're multiplying to find the product of like bases. Accordingly, if we were to extend this on to a to the 8th times a to the 5th, we'd have 8 a's and then 5 more a's. And when we say more in math class, that just means to add. So we can add that 8 and 5, and you would get a to the 13th power. And then you took a few minutes to check it out with division. So we have a to the 5th over a to the 3rd. And I actually, if I'm going to teach this from scratch, when I teach it from scratch, this becomes like a battle line drawn in the sand. So you have 5 A's on top doing battle with 3 A's on the bottom. Or if you're a football player, hopefully we're playing, but if you're a football player, this line right here is like a line of scrimmage, You got 5 players on one side directly across from maybe 3 players on the other. Anyway, they kind of do battle. So if you're doing some matchups, this guy would take out this guy, this guy would take out this guy, this guy would take out this guy, And look what you have left over. You have a squared left over on top. So the quotient of a to the 5th over a to the 3rd is a squared. That's not addition. Maybe you know what it is? We'll find out. All right, take a look at part B. Whoops. And again, if you're a person using notebook paper, you know, you're just kind of copying this stuff down so that you have at least the problem copied there, so that when I go to grade your notes, I can see that you have all this kind of stuff. So just make sure you have your notes copied correctly. So yeah, you would have to copy that. And then the word exploration is super important. Okay. So if we are doing a to the 3rd over a to the 5th, this guy takes out this guy, this guy takes out this guy, this guy takes out this guy. Because remember that if you have a over a, that's just 1. And then a over a, that's just 1. And then a divided by a, that's just another 1. So if you have 1 times 1 times 1, I mean, that's just 1, they go away. And then you have a squared left on the bottom. So 1 times 1 times 1 on the top is 1. And you have a squared on the bottom. So we never have a fraction without a top on it. So what we end up with here is 1 over a squared. And then in part C, those things take each other out. So if these all turn into 1s when we put slashes through things, we basically have 1 over 1, which is 1. So what can we observe from this? Well, basically it's as easy as subtracting the exponents when they do battle. So if we wanted to do x to the 7th over x squared, these two guys on the bottom would take 2 away from the top. So essentially what we have is x to the 7 minus 2, which is x to the 5th. If you wanted to apply that to this guy here, that's the same as x to the 2 minus 7, which is actually x to the negative 5th. And you're going to see that we're not allowed to have negative exponents like ever. And that's how we had x to the 5th left over on the bottom when they did battle. So hopefully this exploration helps you with some of the properties we're going to talk about today. Properties of exponents, fun fact, they're just shortcuts. You know, and I'm not the biggest fan of memorizing in math class. You're going to come to understand that. I'd rather you understand where the shortcuts come from. So if you can make sense of it, you're more likely to retain the property. So it's in this way that everything I teach you today is just like a massive shortcut. So what are these rules? Well, we can start with some that we know. So for instance, we can start with our product of powers rule right in the middle of the screen there. So you would, you know, copy this chart if you're a person using notebook paper. And these are again on page 14 in your book. If you need to pause, you can certainly do that. But yeah, so if you're a pencil and paper type of kiddo right now, you're basically copying the chart and then all of the examples that we have handwritten. All right, so with that, you have your, the first rule I wanted to talk about was the one we were most familiar with. When we had like bases multiplied together, we're allowed to actually add the exponents. So here, if you have 3 squared times 3 to the 4th, we're allowed to do this as 3 to the 2 plus 4, which ends up being 3 to the 6th power. And then you could evaluate that, you know, with your calculator or what have you. We also had our quotient of powers rule down here. And the shortcut there was, you know, they could do battle. This x to the 7th does battle with this x to the 4th. So these 4 x's on the bottom are going to take out 4 of the x's in x to the 7th. Essentially, we're just subtracting. So we would do x to the 7 minus 4 and get x to the third power. We have other properties as well. We have our power of a quotient rule. And essentially, you know, I could actually multiply 2 over x out 3 times if I wanted to do this problem the long way. So I would do 2 over x times 2 over x times 2 over x. When we multiply fractions, we multiply straight across. So you'd be multiplying. If we did this problem the long way, here's how it would look. You don't need to write this part down, purely for your visual entertainment. So we would have 2 over x times 2 over x times 2 over x. And so you'd have to do straight across the top, 2 times 2 times 2, that's 8. X times x times x, that's x to the third. Well, like, who seriously wants to do all that and write it out all those times? I mean, you could if you were in a jam, but that's why I'm teaching you these properties of exponents so that you can kind of, you know, go live your life. So what we're going to do is, as long as there's no plus or minus in those parentheses, we're actually allowed to distribute that exponent in. Kind of use our distributive property. Again, that's if there's no plus or minus in the parentheses. Plus or minus in the parentheses means you're foiling and distributing and all that good stuff. So this is going to be 2 to the third over x to the third, which is 8 over x to the third. This would work for number 4, our power rule. So if we have y to the third raised to the negative 4th power, we're actually allowed to multiply those things together. So that's going to give me y to the negative 12th. And my stylus is not working. Sorry, guys. Okay. Very messy looking. All right, so we got y to the negative 12th. Now I'm going to come back to that in just a second because I got to teach you one of my favorite rules. We're going to go up to number 1 here, and it's called the negative exponent rule, but we give it a slightly different name. I actually like to teach this as a little thing called the upstairs downstairs rule. All right, first things first, negative exponents are bad, guys. Cannot have them. When you see a negative exponent, you need to get rid of it. So I use my upstairs downstairs rule. Essentially, it cooks down like this. If it's negative and in the top, like here, you got to move it to the bottom. Conversely, we could add to this. If we had something that was negative and on the bottom, give me a little room over here. So if we had something that was negative and on the bottom, for instance, if you had 1 over a to the negative nth, to get rid of that negative exponent, that negative n that's right there, because this guy right here is bad, we have to get rid of him. It's negative n in the bottom, we got to bump it to the upstairs. So a to the nth gets a promotion. And you can put it over 1 if you want to, but that's not required. So y to the negative 4th, well, I see that bad guy sitting there, that negative exponent, and it's in the numerator. So if I want to make that positive, I just have to move it to the bottom. And remember how there's always a coefficient in front of a variable? Well, that coefficient gets to stay on top because it actually has a power. 1 is just the same as 1 raised to the first power. Positive exponents are okay. He can stay put. It's the negative exponent that had to make the move. So let's look at that y to the negative 12th again. It has a 1 in front of it, but 1 is raised to the first power. 1 to the first power is 1. That can stay on top. Y to the 12th has to move to the bottom. I love the 0 exponent rule. It's awesome because anything raised to the 0th power is actually 0. I lied. It's 1. I said that wrong. Oh, dear heavens. What a way to miscommunicate. Okay, anything raised to the 0th power is 1. We actually did this in the little exploration I had you do. I don't know if you noticed it or not. It was in part C right here. So let's take a look. Go ahead and flip back for a second. Do you see how we had a to the 3 over 3? I'm sorry, a to the third over a to the third. And we got 1. Well, remember, according to our quotient property, we're allowed to subtract these exponents here. So this is the same. If we look at a to the third over a to the third, that's the same is doing a to the 3 minus 3, which is a to the 0th power, which gives you 1. It makes sense, you know. You learned early on that like 7 over 7 is 1. 10 over 10 is 1. Well, a to the 3rd over a to the 3rd is also 1. So another way of looking at that is just your 0 exponent rule. It is 1 because it results in a 0 exponent. How's that? Pretty cool. All right, so with that, go back to our chart here, see how we're doing. A couple more here. Anything raised to the 0th power is 1. And then right here, we again, no plus sign or minus sign in those parentheses. You're allowed to distribute that exponent in. So this is going to be 5 to the 3rd times x to the 3rd, or 125x to the 3rd. So that, my friends, is just a quick review of your properties of exponents. We're going to give it some practice. Okay, we start with just numbers. Sorry, feeling a little impersonal there. Thought I'd add my face. So what you're looking at here, oh my goodness, there we go, is -5 squared. And we talked about this earlier. When you square a negative number, -5 squared, you're taking -5 times -5. You're taking the whole thing and squaring it. So we're doing -5 times -5. That's going to be a positive 25. However, if you look at part B, that's -5 then squared. Well, order of operations says I have to square or do the exponent here before I multiply by that factor of -1 out in front. So this is like -1 times 5 squared, which is the same as -1 times 25, which is -25. So that's a little reason why these two things are actually very different. They evaluate to different products. Part C, when you look at it, we're going to go ahead and use our addition rule for our exponents. I have basically 2 to the 1st power times 2 to the 4th power. Well, that's the same as 2 to the 1 plus 4, which is 2 to the 5th. And then 2 to the 5th is 32. And again, if you're taking notes on paper, you have example 1, you copied A, B, C, D. I think you're starting to pick up on that, but I'll go back occasionally and highlight it for you. All right, part D, we got 4 to the 4th over 4 to the 6th. So I'm going to go ahead and notice that I have like bases there. I have a quotient of like bases. So I can take a few seconds to just subtract those exponents. So I have 4 to the 4 minus 6. That's the same as 4 to the -2nd power. And then I'm like, uh-oh, I got a negative exponent. So I'm going to use my upstairs, downstairs rule. So 4 to the -2nd has to move to the bottom. And then if there's no top, we put a placeholder there. That's 1. So we have 1 over 16 as the simplification of 4 to the 4th over 4 to the 6th. All right, now you get to practice. Go ahead, press pause. Let's see how it goes. Did you get them right? Here's hoping. Usually the one that's most missed is part D. We have 3 to the 5th over 3 to the 8th. You can use your quotient property to subtract those exponents. So you end up with 3 to the -3rd. And then you got to use your upstairs, downstairs rule. So that's 1 over 3 to the 3rd, which is 1 over 27. All right. Wouldn't be algebra class if there weren't an x in it. So let's do it with some variables. Take a look at example 2. Looks like a mess, right? I think, personally. Not to be mean to this problem, but, and then let's be honest, that's a little messy looking. So what we're going to do, I don't really like the way that looks. I'm going to tidy it up a little bit. And here's how I'm going to do that. I'm going to use, remember those properties we talked about in the first section? We have like an associative property and a commutative property. I'm going to go ahead and use those properties. So here's how we're going to do it. I'm going to regroup. So see how I have some numbers in the problem? I'm going to go ahead and put those together in their little group because it's all multiplication. I'm allowed to reassociate multiplication courtesy of the associative property of multiplication. And then I have some A's that I can go ahead and put together. And then I have some B's that I can go ahead and put together. And then I can just use my properties where I just add the exponents, right? Not with the product of -3 and 4, though. That's easy. We'll just multiply those two numbers together. You get -12. And then a to the first times a to the first is a squared because you add the 1s. And then I can add 4 plus -3. 4 plus -3 is just 1. So that's b to the first. So if you just like put the like things together, not like terms because there's no plus or minus, but you know, the integers together, the a's together, the b's together, if you put the like factors together, if you will, the problem becomes a lot easier to work with. Part B, you'll notice there's no plus and no minus in those parentheses, which means we get to use what I kind of call the distributive property for exponents. We don't really have that, but I know that a lot of you think about distributing when you see parentheses, so it's not necessarily a huge stretch. But because there is no plus or minus, I'm allowed to do this. If you see a plus or a minus in those parentheses, you can't do this because you have to FOIL. So what we're going to do is we're going to raise 2 to the third power, and then x to the third power, and then y squared to the third power. You could write it out 3 times if you want to, or that would be y to the 6th. So what we get out of that is 8 x to the third, y to the 6th. All right. Part C, we have 3a as that first sort of set of factors out in front there. And then do you see how all of this here gets raised to the 0th power? All of that got raised to the 0th power, which means that just turns into 1. And then 3a times 1 is just 3a, so that's not bad. Circle my answers here. And again, if you're a person using notebook paper, you have this, 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 and this all copied. Okay, and the last one. If you look, there's no plus or minus in those parentheses again. So I am going to go ahead and push that exponent in. Ooh, yellow. That's not bad. I thought that was going to be later than it was. So we have 5 to the 2nd power, x to the 6th power, because 3 times 2 is 6, and then y to the 2nd power on the bottom. And then I usually write 5 squared as 25. That's what the big kids do. I'm going to leave 5 squared there. So now that's completely simplified. All right. Thanks for hanging in. You're doing great. All right. And then just adding a couple layers to this, making it just a little bit trickier because you upperclassmen can handle the truth. All right. Let's see here. Again, if you're a person using, whoa, sorry. If you're using some notebook paper, you're going to want to go ahead and copy some things for me, like this, and this, and this, and this, and that. All right, so making them just a little bit tougher. Not too much tougher, though. For instance, if we have x to the negative first, we kind of talked about that. That's just going to be 1 over x. Taking a look at part B, what I need to remind you of in this example, I'm going to get rid of this for a second. There we go. What I need to remind you of in this example is that numbers have exponents. So you see this 3 right here? It's raised to the 1st power. I have a question for you. You're going to answer it in your head. You see that 1 I just put there? Is it positive or negative? Yeah, you're right. It's positive. Okay. Positive exponents don't need to move. They don't. The bad guys are the negative exponents, which means that this 1 is also raised to the 1st power. It has a positive exponent. Positive exponents always stay put. it's funny, like my students will think like these two things are like married until like death do they part, like you're not allowed to break them apart. But what I need to let you know is that like they're just factors. This is multiplication in here. So we can move multiplication around. Those are the properties we talked about in the first section. So if you have 3 to the first times x to the negative second, well, that x to the negative second is a bad guy. It's going to need to move. And since it's negative in the downstairs, to make it positive, we just move it upstairs. So that x to the second actually has to pop up on top. So this guy here is just 1x squared over 3, or some people would write it as x squared over 3. Either one of those two is great. But notice the 1 and the 3 stay put. Okie dokie. Part C. Again, you know, your exponents, or your numbers, I should say, always have exponents. So this -5 is raised to the first power, this z is raised to the first power, and since there's no plus or minus in those parentheses, I can distribute that exponent in. So if I do -5 to the third power, that's -5 to the third, so it's -125. And then this becomes z to the third. And then we still have the z to the second hanging out there. And then I notice I have like bases multiplied together. I can just add z to the 3 plus 2. And you don't need to show that addition step. I'm just showing you what's going on in my head. So I'm thinking most of you would just not even show that step. You would just do 3 plus 2 in your head, which is fine. Hoping y'all can handle that at this point. All right, so we got -125, z to the 5th. My rule for these, by the way, when you go to do your practice at day, you know, tonight, tomorrow, what I need to let you know is that I require just bare minimum 1 step worth of work and then your answer. So you don't have to write me a novel. I mean, like I say, I've said before, you have a life too. I get that. I need 1 step worth of work and then your final answer. Except for maybe on a problem like that. Don't worry, I won't judge. That one's fine. Okay, part D. Again, 3 has an exponent, so we need to do that distributive property to every exponent in the problem, again, as long as there's no plus or minus. So this becomes 3 to the 1 times 2, which is 2, x to the 8th, x to the 4th, and then y to the 4th. And then I'm not quite done for what I can see right now is 2 reasons. 3 squared, we can simplify that, that's 9. And then also if I have x to the 8th over x to the 4th, again, I'm allowed to subtract 8 minus 4. 8 minus 4 is just 4, y to the 4th. Now if this 4 here ended up as negative, I'd have to put it on the bottom. So if this problem presented as the reciprocal, my difference would be on the bottom. And that's that. All right. You get to try. Go ahead and press pause. We're going to see how you do. There they are. Hopefully G and H were a breeze, because those were from example 3. You'll see I showed a lot of work there on part L. You don't need to show all that, but I did take it step by step. And I'm going to talk about that one now. If you need the other ones talked about, we can definitely talk about it during our Zoom tomorrow. Not a problem. So that's usually what we're going to go over in the Zoom after you watch a video. So if you watch a video and you have questions, they usually get answered in the Zoom the next day. So if you're looking at this guy here in your notes, and you're like, what do I do? The first thing I did is I noticed there's no plus or minus in that parentheses right there. So I went ahead and I distributed it in. And then I also did that in blue with 4x to the 3rd raised to the negative first power. I then went ahead and I simplified a little bit. Like for instance, -2 to the 3rd is -8. And then 4 to the negative first is just 1/4. And then I did that super cool thing where I grouped the numbers together. And then I group the letters or the variable parts together. That's that associative property of multiplication we were talking about where I regroup things. So 1/4 of -8 is just -2. And then 6 plus -3 is 3. So you end up with -2x to the 3rd. I hope that helps. All right, last bit of today's lesson is a little scientific notation. And remember how I went on that rant about how, like, we don't do negative exponents? This section turns me into a big fat liar because scientific notation is actually the one spot where you can have a negative exponent. Let's talk about the definition. The definition of scientific notation, super simple. A number is written in scientific notation if it is expressed as a product of a number n, such that n is somewhere in between 1 and 10, not including 10, and then 10 raised to a power. Again, if you're taking notes, you're going to want all this good stuff written down. All right. So for instance, a number that is in scientific notation might be as simple as something times, we'll do something with pi in it, 3.14 times 10 to the 8th power. That's in scientific notation. How do I know that? This number here is a number between 1 and 10. I have a product, and then on the other side of that product is 10 raised to a power. So that meets the definition for being scientific notation. Now, if I shimmy that decimal over one spot to 31.4 times 10 to the 7th, well, yeah, I have an equivalent expression, but 31.4 is not a number between 1 and 10. So that can't be scientific notation. This violates the definition. So let's give it some practice. The first thing we're going to do is write some numbers in scientific notation. The rule I have is we move the decimal point until you get a number n, such that n is between 1 and 10, not including 10. And then I just count the number of moves I make. So that's kind of what I do. So for example 4, oopsie, that's supposed to be a highlighter. Example 4, I'll copy those down. So in part A, we have there are 359 billion gallons of water on Earth, because the Earth is mostly water. So are you, actually. Fun fact. All right, so we have 359 billion. So there is 359,000 million billion. And normally my decimal point's hanging out right here. So I need to move that decimal point so that I get a number between 1 and 10. So if I move it here, I'm not there yet. Here, here. Well, now I'm at 359 million. Here, 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 here. Now I'm at 359. 35.9, still not between 1 and 10. Oh, I got to slide it right there because 3.59 is the number between 1 and 10. And then I just count the number of moves I make, and that becomes my power of 10. So I got how many swooshes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 swooshes. So 3.59 times 10 to the 11th power. Back in 2012, the year my son was born, Westview's population was 6,759 people. Small town. I like Westview. Small. So we got 6,759. I always copy the problem. And my decimal point's hanging out right there. So I need to move this decimal so I get a number between 1 and 10. So that's going to be 6.759. And then how many swooshes did I make? I made 3. So that's my exponent for 10. All right, now look, part C and D, I have small numbers. Those are decimals. They're not big. Well, what does that mean? All that means is that my exponent for 10 gets smaller. Small number, small exponent. So I'm going to go ahead and take this guy right here, and to make it a number between 1 and 10, I really only had to move that decimal point one spot. So that's 2.85. 10 to the first would make this number, if you think about it, if I wrote that as my answer, well, 2.85 times 10, that's 28.5. That's not the number that's written in part C. If I want that number to get smaller, I have to make the exponent smaller. And how do you make it smaller? Make it negative. Shove it to the other side of 0 on the number line. That'll make anything smaller. So what we have here is 2.85 times 10 to the negative first as our answer. Same thing here in part D. So 1, 2, 3, 4 swooshes. But that's a really small decimal. So I can't have a big exponent. I got to have a small exponent. So it's not going to be 4 because that's going to give me like, 56,100. That's too big. So to make it small, I have to make the exponent small. I have to make it negative. So hopefully that helps. Some students will be like, oh, you move it, if you move it to the right, it's negative, blah, blah, blah. I just think small number, small exponent, big number, big exponent. That way, if your right-left challenge maybe like me sometimes, not so bad. Now we go in reverse, and this will be our last example of the day. You're doing great. What you're going to do is basically just move where the exponent tells you to. So if you have a big exponent, you got to make a big number. If you have a small exponent, you got to make a small number. So here in part A, 10 to the 4th is a big number. So if I want to make 2.1 bigger, I got to add some zeros to the right of it. So I'm going to go 1, 2, 3, 4. And then I'm going to fill zeros in that blank there. So 2.1 times 10 to the 4th is 21,000. Part B, I have a negative exponent there. 3.26 times 10 to the negative 5th. That's going to be a smaller number because 10 to the negative 5th is small. I got to move it 1, 2, 3, 4, 5 swoops. And then I fill in some zeros. So this ends up being 0.0000326. And then lastly, 1 times 10 to the negative second is the same as 1.0 times 10 to the negative second, if that helps you at all. So I got to move it 2 swoops to the left because I'm trying to make this a smaller number. And I would put a 0 in as a placeholder. So I get 0.01 as my answer there. And again, if you're a person taking notes on notebook paper, you have all that good stuff written down. All right, time to wrap it up. You get to go ahead and practice. Don't worry, Ross Township citizens, not McCandless. I didn't leave you out. The population of Ross Township in 2010 was 31,105, and I want you to write that in scientific notation for me. There's also another one right below it. Go ahead and press pause. See how you do. Did you get them right? Nice job. All right. Second video down. You guys are doing awesome. All right. If you have any questions on the video, hit me up on email or come see me in Zoom. We'll talk to you soon.